Well, hello there, and welcome to this latest webinar with TRL, looking at some of the most exciting technology in the transport industry. And today we're talking split cycle offset optimization technique, which is, of course, Scoot to you and me. Hello, I'm Paul Hutton. I'm co-owner of Highways News, and I'm really looking forward to this hour as we discuss Scoot, because I remember when I first came into the industry in 2000 and I was new to absolutely everything, I was visiting an urban traffic control department and was blown away by this thing called Scoot that changed traffic signals based on congestion levels. Well, the Scoot I saw then was nothing like the Scoot that was around originally nearly 50 years ago. And to be honest, is nothing like the Scoot that we have now, because now we have Scoot 8 AI, the world's first AI-powered predictive UTC solution. And we're going to find out all about it today with our two guests from TRL Software. They are Chris Kettell, who is Chief Technologist, and Traffic Engineer Wendy Davidson. So they're joining me now, and you will have a chance to ask them questions later on. So let's just do the admin now, shall we? You'll see the Q&A tab on your Zoom screen. If you want to ask a question, please type it in there and we'll get to as many of them as we can through this hour. But as I say, Chris is an expert in all things Scoot. And Chris, it's been trusted in more than 350 towns and cities worldwide for nearly 50 years in some cases. But for those new to Scoot, could you give us a quick elevator pitch, I guess? What is Scoot and why has it been such a trusted part of traffic control for so long?
Okay, good afternoon. First off, can you hear me okay? Have I pressed all the right buttons?
Yes.
Wonderful. Okay, so as you said, Scoot, well, split cycle optimization technique. It's been around for nearly 50 years. And over those 50 years, it's been a trusted solution provided by the two traffic signal partners. At the point of TRL actually being able to bring Scoot directly to customers ourselves with TRL UTC and Scoot, we've continued with our role as the design authority, the originators, creators of Scoot, and have now moved that ahead over the past 3 years worth of work into Scoot 8. So TRL, UTC with Scoot 8 is what we're bringing forwards. And that's really quite a significant thing. I think we can say this is really probably the largest upgrade that's going to have been seen in Scoot's history. And part of what we're doing, as everybody else is bringing AI into the mix, we're looking at the use of artificial intelligence, focusing on the outcomes from that, and starting to head towards reactive or moving away from reactive optimization, that sort of cycle by cycle, to predictive control, where we're using embedded AI for flow forecasting, incident detection, and ultimately for corridor management. That, in terms of the original ethos and underlying principles of Scoot, is a significant step change in making something good even greater, that's available from us here at TRL Software.
Okay, so we've reached the top of the building in the elevator. So now let's get into some detail because I want to know more. So, I mean, I guess what is the major leap forward between Scoot 7 and now Scoot 8?
It always makes me smile to see feedback, and marketing stats on improvements on congestion. It slights congestion by 50%. Congestion delay all improved significantly. Sort of looking at from a bottom line, a universal 15, 20, 30, 40% reduction improvement in congestion, network delay isn't credible. It's not a credible claim to be making. It doesn't stand up to scientific method in any way, shape, or form. If you have a more tiered claim for that, so network wide, you might look at an average of single digit improvement, mid teens, sort of at your congested hotspots. and then maybe up to 20% or so within specific recurrent sort of hot hours or pinch points where you end up with periods of sort of oversaturation. That's a well-known thing. So delay explodes as you near saturation, as the roads get busier, as you have more spillback, more traffic that's building. Working originally with the Alan Turing Institute, where we were host to a couple of postdocs, we've developed, and in true keeping of TRL for its acronyms, model internally GTT9, based on the underlying traffic and the technology that sort of works for that. Rather than looking at the older approaches in let's call it modeling in the loosest sense of the term, where you can consider spatial or the temporal elements to how traffic moves through your network. What we're essentially doing is shortcutting that part. You don't require a microsimulation model. What we require is to have been on your network, taking flow data, control data, and learning from how your network runs. In using a combination of something called a graph neural network, GNN, and transformers. So some clues as to what you get in that GTT9 part of the name. We're running with sort of spatial inference and then temporal inference to actually get some really quite robust flow for different elements of the network.
Okay, so if it's the world's first predictive UTC, what actually, it sounds very exciting, very nice, but for somebody who's worried about movement of people and goods around a city, what difference does it make for them? What's so great about it in practical terms?
Okay, so in practical terms, the way in which one of the underlying principles to Scoot is in the formation of the cyclic flow profile. And so looking at the arrival rates of vehicles on a road or a link. And that's based on data which comes from typically inductive loops. The change towards above ground detection, vehicle classification, that emulation of what connected will ultimately start to look like as technology matures, becomes more adopted, and becomes more widespread and available. And so this is a halfway house in being able to say, what's there right now? How do we make this better? And so just taking loop data alone, sort of that, as it's been for a very, very long time, if I was to go back to the two postdocs, and they wanted to understand, new to traffic, meant nothing to them. They thought I was joking when I talked about inductive loop, the 4 Hertz sampling that goes through, and occupancy 1001 every second. They thought it was a joke. Surely not. You can't be controlling traffic from that. And it was a real eye-opener. And from that came the, wow, they were surprised. And it made me look and question things in different ways as well. And part of that was really understanding where we'd come from and direction of travel in what was possible. And from that, one of the first things that we looked at doing in terms of being able to actually improve was to say, where does a better input enable a better outcome? What does that look like? And so the absence of going to all of the effort of building a large scale microsimulation model, going through and doing all of the verification validation that's required within that, and actually taking some of the existing data that we had, some data which is new, novel, that doesn't fall into the, you need some UTMC to bring this data in. We're now able to actually forecast in a 5, 15, and 30-minute time horizon as to what will the traffic state across the network look like over those periods. And so that's a shift from being reactive to it being proactive. And so looking at the changes that Scoot makes, those small incremental step changes, to be able to highlight and identify where you will have issues before they've occurred. Knowing a problem is coming, knowing that your volume capacity ratio is going to get above that 90–95% element, you can do something about that. And doing something about it early is a great example of where a stitch in time saves nine. It's that, well, you're preventing a problem, it then doesn't occur. And that's really where some of the clever comes into this.
So what you're saying is basically you've got the ability now to spot where traffic jams are going to happen and actually mitigate against them before they happen so that they don't happen.
In essence, yes.
Fantastic, because this was actually what I was about to do, was go, well, can we see it? And so we're going to do that as long as Zoom lets us look at this. We're going to see Chris's screen and we're going to find out more about it now.
Okay, so where we talk about, firstly, the ability to forecast. Let's jump onto a link. So let's pick an interesting one. Let's go down here. Have a look. And for the link details. So in building up a flow profile, this is from data a week or so ago, we're able to look at and see actually what happens across the time range of interest. And in providing the what's just happened, we can start looking at what does a forecast from the AI element of this look like. And so we capture the spatial and the temporal distribution as to what that looks like. Now, this is just a 5-minute forecast. We've got it at the next level of detail, which then works on a per cycle by cycle basis. As we then roll out those forecasts for what's going to happen over these time periods, we actually capture with some very high degree of accuracy. So for the 5-minute, using the mean average percentage error, or MAPE, getting scores from sort of less than 6% down to 1.1 are absolutely fantastic. And being able to do this in a repeatable way and building up a body of evidence and knowledge and benchmarking and saying, here is where it is good. Now, I'm not going to tell you it always does this all of the time. It's the best thing since sliced bread, because we do get times where actually the quality of the forecast based on what we've trained with the model doesn't quite fit. And so our error margin actually jumps above that, which would be acceptable, useful, not cause us a mischief. And so by going through and looking at what the quality of our forecasts are and running through, that gives us the ability to actually start making slightly different changes to how Scoot would have worked from Scoot 7 and all prior versions. And so we're looking at what's happening at a stop line level, and so understanding the current and the predicted future cycles and what traffic we're going to see within that, considering the spatial dimension, where things are, what's coming in from upstream, what's happening downstream, and then looking at things as corridors. This is really where the good and the really quite, yeah, I won't be myself. It's fantastic. I've been really pleased with the results and the quality as to where we've got so far, and doing all of this without needing to actually undertake any sort of form of micro simulation. Confidence ranges, the quality in being able to use this on a link by link, node by node, junction by junction, improves the data on which Scoot makes its decisions, and it makes them better, that higher fidelity. And so moving away from being reactive, we get a smoother progression, faster adaptation to changes. We reduce the congestion risk early and front up. And so where you're talking about policy-driven approaches to how you want to run particular elements of your network, how that fits together, it starts to become really quite a powerful tool.
Okay. And you say it's a tool. So you're getting the data, you're doing the prediction is happening, it's looking into the future. What happens next? Does that then automatically start retiming signals, or is it a series of options that a human being looks at, and it remains the human being's decision as to what to do with the extra knowledge they now have?
I recently bought a new washing machine, and my new washing machine has AI inside. I don't care about the AI inside my washing machine. I don't want it. I don't need it. I'm not interested. It's a bit like the what is useful. And so how we're bringing this into TRL UTC with Scoot 8 in the first instance essentially is like a shadow mode. So it runs in the background and it will give you the ability to look at what would Scoot 8 have done rather than, or with AI, as opposed to what would Scoot normally have done. So baselining it against version 7 from TRL. The purpose of this is to be able to build confidence and see that what we're forecasting on a link by link basis is on par or better than what would have been given just on its own. And so building that trust, that gradual proof that the decisions which are coming out are reliable before we then shift into an advisory mode. Step 2. Hey, I think we should do this. Would you like to do this? Getting the operator involved, building that confidence, the feedback ability of saying, we've made these changes. Here is what's going to happen downstream with this particular critical short link. Here's what's going to be happening upstream. And those recommendations will have a time period over which they're valid. Nope, you weren't interested in that. Let's keep going. The ultimate target to that is to reduce the level of operator input which is needed and have the big button of just do it. That would be a nice place to be. That's some time off.
Okay, right. Wendy, we will come to you, I promise. Chris and I are not just having a chat together, but I want to ask you one last question before you bring Wendy in to talk more, Chris, which is about also the fact that if you've got all this data coming in and you showed there the graph of what's normal versus what's not normal, is there an element then of incident detection where something is so way off that there must have been a crash or some sort of roadworks or some other reason for that change in normal behavior rather than just sheer weight of traffic, for example?
And absolutely. And this is where this was started from. The original problem was posed for incident detection across your network and using data from ways from cities. If you're a local authority and you're not using it, why not? It doesn't cost you anything to have access to this live data feed, journey times, incidents, jams, queue lengths, flows through your network. It's an incredible tool. Look at it, please. And we started from, if we take that crowdsourced data and what we know from traffic control, taking the advantage of now seeing beyond the horizon of the traffic controlled area, can we spot with a high quality indicator that something has occurred which is impacting on network availability to traffic? Yes, we could. And part of the way in which we do that is to look at what would normal traffic flow look like. Oh, well, here's the baseline, but we need to be able to forecast. It was one of those eureka moments, all the light bulbs came on, we went, that flow forecast is a bit good. That fits really well. Let's do a bit more. And the bit more we did, the better it became. And so being able to look not only at how you improve the movement of traffic through your network, how you actually bring down the peakiness, those hot hours, and we keep traffic moving, but also to be able to say, have a look here. Something has happened. Here is something that needs a network response. And so if you're in a large city and you've got thousands of CCTV cameras, the difference in responding to something sooner is so impactful in reducing your return to normal conditions. And so, yes, we have incident response within this. And for those that know Scoot evolved and think Ingrid, no. Put Ingrid out of your mind. You don't need to think about Ingrid, nothing like it.
Okay, fair enough. Wendy, as I say, we'll come to you in a minute because I want to know a bit more about the work that you've been doing with operators on this. One final question for now for you, Chris, which is about corridor management and what difference Scoot 8 makes to that.
Okay, so corridor management, one of the criticisms of Scoot historically has been, oh, if only we could consider a strategic corridor. And so whilst there have been prior efforts in actually how you would coordinate and monitor and evaluate, actually looking at the network as a whole, from a junction to the links, to a series of links, to links and junctions and nodes into corridors, considers the spatial, the geographic relationship between the network, traffic sources, traffic sinks, how things move through. And so bringing in that ability with UTC to consider corridors and manage your strategic corridors with your journey time reliability from the performance indicators that we have from Scoot and UTC itself, really steps up that toolbox of interventions, controls, and importantly, feedback mechanisms for someone that's responsible for how traffic moves through an urban area. It's pretty damn cool.
Excellent. Right. Just a reminder, if you're watching that you want to ask a question, go in the Q&A section. We've already had a couple of questions come in, which we'll come to a little bit later on. Go to the Q&A section on Zoom and you can put your question or comment in there. Wendy Davidson is traffic engineer at TRL Software. Wendy, you mentioned, or Chris mentioned about shadow mode and advisory mode. Before full automation, how are you building confidence with operators using that?
Sure. So like a shadow is something that runs in the background, isn't it? It's something that's always behind you. So what we do is the AI runs in the background of the UTC system, and it compares what Scoot 8 would have done versus what actually then happened. And that gives the operator that information and the data that they need to gain that little bit of confidence in what Scoot 8 is thinking and where Scoot 8 would have taken it had it been in control. So that's what we do with shadow mode. So it's really just reinforcing that information for the user. Then in advisory mode, we take the AI to the next level, which where AI actually makes the recommendations to the user, like to the operators, and the operator can choose when to apply them. Now, these recommendations are simple recommendations that the operators will understand. It will be stuff that's within their scope, normally on a daily basis. So it's not going to be some high-level recommendation that they're not going to know what it means or know what to do with it. It will be, simple things like changing the green timing on a link because that will impact the next node up. That will impact the progression. And by doing that, by using first of all the information, giving the information, and then secondly making that bit of advice at a level that the operator understands, we're hoping that we're going to build trust gradually, and it will give proof to the user that the AI decisions, the recommendations that the AI have made, are reliable enough for them to have confidence in flipping to that full automation status where UTC will do it all for them.
Okay, so I imagine now I'm an operator in a control room. What am I going to see? What tools do I have now in front of me thanks to Scoot 8 AI?
Okay, so what we are generally looking at as traffic engineers, so we're looking at traffic engineers that use Scoot, I should say. So we're looking at things like delays, stops, queue lengths. We're all interested in emission with all the emission targets we have these days as well. So we have real-time dashboards within Scoot 8 that display this information in a clear and understandable way for the traffic engineers. The visualizations within these dashboards will give predicted flows, and as Chris mentioned earlier, those incident hotspots. So we identify those pinch points in the network as well. And then, like I mentioned in the last question, we're then looking at making easy and simple recommendations to the users through these dashboards, such as, extend the green on this arm. We want to make sure that this information is transparent, and it reports that these reports within these dashboards actually, again, build upon that confidence that the operator has, that they can make the changes that we recommend.
Okay, now this is something that I've come across in years and years and years of writing about brilliant technology in transport. And Chris talked about the significant percentage increase or improvement in network performance. But the issue is, right, if you have lots and lots of congestion in a city, the cost is to the overall economy. to just either people going about their daily business or just, the overall loss of productivity. If you spend money buying a system and you're a local authority, then the benefit goes into it's fairy gold. It goes into the overall economy, but nobody is going to walk up to you and say, hey, Malcolm, here is a check to say thank you for the improvement in the general level of congestion in your city that has made the economy work better. So how do we work out an ROI on the fact that you're investing in better network management within your city?
Sure. Okay, so what we've done is we've put a real effort in the design of our dashboards to make sure that that ROI you've spoken about is transparent and reportable. The immediate benefit to the network as a whole that you'll see is a reduction in journey time. So we'll have those journey time savings. At the moment, we're averaging about 10 to 15% on the network that we've done our training on. Typically, this will give a payback within 12 months due to the reduced delays and operating costs. So a 12-month return on investment, I think that's right up there with great value for money.
Chris mentioned earlier, Wendy, about the fact that there were other benefits beyond journey time savings, and we talked about environment and so forth. So what sort of savings can we look at beyond the journey time?
All the things that are hot topics. So beyond journey times, the focus in local authorities that we've noticed the trends across the UK is talking about sustainable benefits. So things like air quality and emissions. Also, active travel is really high in the agenda. So by reducing those delays in the network that we've talked about, you're looking at lower emissions. Fewer stops means less vehicle idling time, which is a reduction in your CO2 emissions. So there's we can correlate that directly. The other thing we've thought about is with less stops in the network, we've got fewer queues. So we're reducing that, not only the idling time, but the possibility for rear end collision. So we can look at that safety aspect as well because of that. Because obviously we're keeping that network actually flowing as opposed to that stop-start situation. And then active travel, I think was the other thing I mentioned there. So we're integrating pedestrians. And then obviously we've got cycle signals that we can actually include in there. So we're balancing flow fairly between pedestrians, buses with bus priority, and then you're on obviously general car population. By using that bus priority, we're obviously giving benefits to the public transport. So we're giving a more reliable bus and potentially trams if you've got them within your network journey. And hopefully by doing that, we then in turn see that modal shift as well that everybody is striving for within targets that we see these days.
Now, that's really interesting because that was one of the questions. I'm just glancing over onto my other screen where questions are coming in. Andrew Rawlinson exactly asked that question about how is safety and driver and pedestrian comfort catered for. I guess you've kind of answered that. Is there anything more that you want to add on Andrew's question?
Well, I think that's one of the real strengths of our UTC and Scout 8 is that multimodal priority. We're able to do all of those. You don't have to. The AI within Scout 8 makes that decision for you. You don't have to put the emphasis necessarily on bus priority or on pedestrians because we look to balance it. And I think that is one of the key points within Scout 8 is that we balance that demand.
Okay. Now I'm bordering on PTSD a bit, especially when Chris was talking about the fact that my degree was in mathematics and I was clearly such a great mathematician. I went on to have a career in journalism, but some of the stuff that Chris was talking about, I remember looking at the very basics of many, many, many years ago. But one of the things that came up, I remember when I used to go and visit lots and lots of UTCs around the country, was the amount of time that the people I would be talking to were spending talking about validation and then revalidation of their data, and talking about the maths that went behind it, that I kind of could keep up with. How does this new solution, how does Scoot 8 actually help, or does it help reduce that workload that's so time and labor intensive?
Yeah. Okay. So, yeah, how often do we hear about a scoot junction that goes in and then is left for 10 years until somebody complains, and then we revisit? 10 years is a long time. And when we see the growth of the networks across the UK. So Scoot AI continuously self-calibrates the models, moving much of the validation into the system itself. So realizing when there is a change in the flow in a particular link, or if we have detection of a higher rate on a particular link, this automated revalidation, or that recognition, removes the need for repeated manual studies, because that information is displayed on the dashboards all the time. So you're not having to go back out and take those measurements yourself. We've got that data within the system. So we have within those dashboards that provides auditable, can I get that out? Evidence of performance, which then saves engineers those weeks of effort that you described there.
Okay, now here's a great question from Derek Hooper that I've seen that has come in. That he asks, what data sources can be utilized by this new version, and going forward, how do you see Scoot interfacing with driverless vehicles? Let's come to that in a moment, but let's first of all talk about the data sources now, because Chris, could you talk a bit more about, you mentioned ways for cities, but what other data sources? Do we need new ones, or can you work on legacy data that's already being created?
Hello again. That's the great thing about data. I think back 20 years and being in a traffic control room, God, if only I had some more information that was available to me. And today it's shifted to an extent to being more of a fire hose. And so you've got to try and find what's the right data at the right time, from the right place, with the right coverage, and is actually useful. And increasingly part of that is with your credit card in hand, because it's going to cost you. And so we've got the what detections there right now. So we're talking about on street, we're talking about inductive loops. Have you got scoot loops? Have you got mover loops? Are they in ground? Or are you actually starting to move towards more above ground detection? Is it radar? Is it computer vision? The stuff coming from Topaz with the enhanced detector specification, hey, it's no longer 100100111 for occupancy and flow, that lovely hybrid, but it's a bus, it's a car, it's a motorcyclist, it's a cyclist. And bringing that data from roadside starts to see us having a far richer data source, data set as to what are the actual classes of vehicles moving through the network. And so what we're doing now, yes, it is link profile unit based. There will be transition from LPU to vehicle as part of Scoot's continued evolution. Let's say Scoot 9, possibly even 10 that comes. And that's the baseline. That enhanced detector information that's coming is a massive enabler. And so starting to layer that in today with journey time information, I cited Ways for Cities. It's a fantastic resource. From signing up, being granted your account, you can start receiving journey time information for your links, for your routes within 2 to 3 minutes. Very, very rich, very, very useful, hasn't cost you a penny. It integrates natively with TRL UTC. You don't need a UTMC solution for it. And so starting with that data right now, that's your starting point. TRL has the Smart Mobility Living Lab testbed for connected and autonomous vehicles. It's the autonomous that's always been the sexy part, not the connected. It's the silent C in CAV. It's a shame. And so the work that we're doing, our roadmap, our continued R&D, also looks at that LPU to vehicle-based optimization and how you optimize vehicles to occupy the right road space at the right time. And so that comes in over time.
Right. Okay. So yeah, because it's our mutual friend Andy Graham will always talk about it's connected and big pause autonomous vehicles, because connected is very much here and now and probably underutilized because everybody's looking to the future and autonomous. But the fact is that that Derek asked about autonomous vehicles, and I ran a story last week or the week before about Milton Keynes using Scoot 8. So Wendy, I suppose the question is, what's happening in Milton Keynes? And the reason I'm particularly interested in asking that now is, of course, a parallel project that's going on is the Omeo driverless shuttle project that's taking place in that very city.
Yeah, now Milton Keynes has got a lot. They've got great ambitions of where they're going to go and their zero emission future. So yeah, they've got their autonomous shuttle, as you mentioned. So a couple of weeks ago, they opened that up to the public. It's actually been running for quite a while that shuttle actually learned the traffic signals and the patterns and the network as such. And a couple of weeks ago, they opened it up to the public. And what I found interesting was they had a 6-hour period that was open to the public. The shuttle can take 8 people for every journey. And they had a queue of over 120 people that day. So that little shuttle worked to capacity all day that day. So it's great to see that there is that. I thought there might have been a fear from the public getting on autonomous shuttle and how is that going to work? But the fact that there's so much interest in it, I think, is amazing. And obviously with that, with the implementation of Scoot 8 and a TRL UTC in Milton Keynes, we're doing a lot of work to make sure that we're moving from, at the moment, how it works is it recognises the red, amber, greens of the signals. Obviously, we're looking at advancing from that and actually having that communication between the autonomous shuttle and the actual controller itself, rather than just the signal heads. So lots of exciting stuff coming in Milton Keynes. They've really got some bold ideas of where their future is going to be.
Okay, we'll keep an eye on that one, and I'll be reporting on that on Highways News in the future. Tony Earls asked a really important question, because we've seen this so often that the problem, and you kind of touched on it, Wendy, with data, is the fact that if you lose some of the sensors, or somebody digs up one of the scoot loops in the road, as we've touched on, then everything can go haywire. So can Scoot 8 AI use proxy data or other strategies that are maybe more reliable when things go wrong?
Yes, that's a simple answer. So, I mean, it's such a data-rich system that we're looking at with Scoot 8. The information that we're gathering, the forecasting that we're doing, there's so much data there. So we're, traditionally with Scoot, we had a historic flow information. We've got so much more with Scoot 8. So we're not only are using that same information that we used to use in Scoot 7, but we've got so much more information on top of that when the algorithm and the neural network has learned those predictive flows and those predictive patterns. We're going to hold that. So when the loop goes down, like we would traditionally, and you traditionally would go to your historic flows, we now know so much more about the network as a whole that we will use that information with those predictive flows to be able to compensate.
Okay. Now, Chris, you mentioned mover in there. How can you kind of decide to help, or how can cities choose between when to use Scoot, when to use mover, VA? What can you do to assist on that?
That's a lovely question, that. So Mover is superb for isolated junction optimization. Scoot is great for network-wide coordination, but the roads are not always busy. And so if you're running Scoot, you will have periods of low flow where the attempt to coordinate vehicle movements actually introduces delay. And so actually, for a junction, for a link, for a part of your network, what is the right coordination method over what area and for how long is best to use? And so we have some answers for that, unsurprisingly. And so different local authorities will have a different mix of traffic control options available for them. Bone to pick with Andy Graham and Scoover, horrible mashing of Scoot and Mover. Ugh, no. But where you have something that's on UTC that has BA, it has fixed time, it has Mover, it has UTC, you can go with Scoot, and being able to pick what's the right control method at this time, at these locations, is something which will come from within UTC. Again, not requiring a UTMC system because we're bringing all of the data together in the right place at the right time, and we're focusing on the outcomes of the use of AI. It has some substance. Here's what it will do for you. It's not just a flashy word and some jazz hands and hoping that people don't ask the hard or difficult questions.
Okay, and in defense of Andy Graham, by the way, I haven't heard the phrase scuva in over 5 years, so potentially it's something that was quietly agreed to be left to one side. So right, you've talked about flow forecasting, you've talked about incident detection, you've also then talked about the fact that we're talking about Scoot 8, and you're already touching on what Scoot 9 and Scoot 10 could move on to. So how will Scoot 8 continue to develop, and what's next?
We have a roadmap, like every product. Sorry, Chris, do you want to go?
No, please.
We have a roadmap like every product, every good product does. So what are we looking at in the future? We're really looking at predictive bus priority and active travel optimization, because they're so key to local authorities at the moment, and such big talking points that it would be stupid not to be looking to move in that direction. We need to look at the optimizers themselves, looking at refining them continuously to cope with the stuff that we learn through this process. It's going to be it's a steep learning curve, as AI should be. It should be a continuous learning journey. So we'll continually look at the optimizers and the learning behind them. What else? Integration with regional hub data. So looking at those, you talked about the feeds from Waze earlier. So we need to look at what other feeds can we take in and use usefully to help not just look at, we talked about looking at the network, but not every city has its own network. So how do we link those networks? People don't just stay within their city, they move beyond their cities. So how can we look at multi-city coordination? Where is the future for that? And then, we just need to keep getting smarter over time. So the AI is the foundation of Scoot 8, and Scoot 9 and Scoot 10, we're going to build upon that AI, and it's going to keep getting smarter over time. The more information you feed AI, the stronger it becomes. And that's what we plan to do with our roadmap.
Okay, Sean Higgins has asked an interesting question around how you actually, so if I'm sold on this, how do I actually upgrade from, if I'm running Scoot 7 onto Scoot 8?
Okay, so obviously it sits within our UTC system, the TRL UTC system, and it's designed for a smooth upgrade, and it's both forward and backwards compatible. We're using, there's no need to change equipment, so we're using existing detectors and existing controllers you already have. There is a bit of a phased deployment at the moment. We're not going to, like Chris mentioned earlier, we're not jumping around with jazz hands and saying here it is right now, have everything that we've described. It will start in shadow mode, and it will scale corridor by corridor. So we're not going to turn up tomorrow and switch on Scoot 8 and everything's going to be rosy for you. It's going to be a process. But the good thing about this process is that it reduces risk. So we've aimed particularly for a low risk rollout model, so that we keep things easy and straightforward. But as I mentioned, the key to it is really our UTC, because Scoot 8 sits within the TRL UTC.
Okay, so by the way, questions still coming in. So if you want to ask a question, we've got up to 15 minutes left on the conversation here. So do fill in your question and we'll get to it if we can. Right, how can I put this? Other options from other organizations are available. Mark Underhill asks if there's any data to see what improvements TRL Scoot 8 could have over other systems on the market.
So yes, clearly there are other systems which are available, and that's the great thing with competition and free market. So will there be data available to compare and contrast? That's a very, very important question to be asking. If I was sat on the other side of the desk looking at a traffic control system, I'm going to want to know actually how does it perform over what I have at present, and what are my options. I think a key part for enabling that is for consistency in what are the metrics by which success is being measured. And so what's the grounded honesty of those metrics, and how do we shift away from hyperbole of the marketing folks, sorry Stephen, through to the grounded reality, that sort of thing that you can sit down and say, is there a robust scientific method that's sat behind this that gives me a thorough, accurate, and indeed truthy assessment? And so that is what we're aiming for. And as we progress, we start to capture results, case studies, sharing information, working with Transport for Greater Manchester. It is very much around the what does good look like? And we would hope that those with other products will also hold the same light up to what they're offering.
Okay, Stephen, by the way, is hiding behind the caption you can see on your screen saying TRL software. He organised the conversation that we're having today. Another quick question, quick answer that I can give to Anand, who says, missed the first half. Is it being recorded? Yes, this whole thing is being recorded, and so do feel free to share it with colleagues and counterparts in other authorities, for example, to make sure we can share this as far and wide as we can. I just want to check, obviously, that I should imagine the roadmap is an internal thing that you're talking about. It's not something you're going to come out and go, here's exactly what we're planning to do for the future. But is there any way authorities might be, or other potential users might be able to actually get involved and influence the workflow that you're actually undertaking?
Absolutely. So it's very easy to say we are customer centric. It's in the reality, the actual doing of that is very different. If we talk around software engineering, I jump into Azure DevOps. I have a look at a feature which we're developing, something that's there. I can trace it all the way back to a customer conversation. Where did this come from? Why is it there? How important is it? And so with our UTC and Scoot user group, last one held earlier this year, March, April time, roundtable discussion. What are people's issues? What are their challenges? What's common across all of those? What is our own thinking? Let's say we share our roadmap. We set out, here's what we are thinking about. Here's what we think the priorities look like based on what you have told us. What do you think? Yes, yes, Chris. Yes, Neil, this looks good. Or have you thought about, can we have, what about this? And so some of that informs, oh, this needs a bit of a closer look. This is then where I put my R&D hat on and look at the Horizon 3 type things, right through to the, right, hand this off. It's now with the software development and it's coming into product. And so it's around that roadmap, that level of detail being shared most impactfully with the users, with our customers who will use it. If you are interested in seeing that roadmap, if you want to talk to us around what working with TRL software looks like, we would be happy to sit down and show you what we're thinking, what we have, what's coming next.
Excellent. Now, I just want to, there's a political side to this, Chris and Wendy, which is the fact that imagine, right? Let's imagine that you actually hit on something that is so perfect that you can manage vast amounts more traffic through a city, but without any congestion at all. So you can get vast amounts more because you're making the road system so efficient. That will go against some of the political things that I write about that are that, 50% of journeys in Greater Manchester, for example, by 2030, the target is to actually have them on public transport or active travel. So actually, if you make it better to use the car, then you might actually be going against a political ambition. So are there values that can actually help? I guess, I'm just sitting here thinking, I'm almost answering my own question, that you could end up being able to use more of the road space for other things if you can actually get more efficient traffic through a smaller amount of space.
Wendy's waiting to see if I'm going to jump in. Okay. Wendy?
Yeah, I think you as you sort of mentioned, Paul, you pretty much answered your own question there. We do have a big focus within our UTC because we are aware of policies. So it is that multimodal. I'm going to come back to it. The multimodal priorities is a big thing for us. So looking at the bus priority and the pedestrian scoot running at the same time is really important for us. So can we use it for other things? We're already talking about those other things. We're already talking about the connected and autonomous vehicles. That's going to be high in the priority list, isn't it? To create space. I mean, what does the future hold for that? Are we going to see dedicated lanes for those kind of things within our network, so that where we've freed up that capacity because we don't have that congestion? Are we going to be able to change lane usage and for the future for things like that? So these, in short, I think there's lots to come, and can I give an answer today of what I would do in that perfect scenario of zero congestion, perfect journey times? At the moment, no, I can't, because I just think there's so much ahead of us in terms of change and where we're going to go with connected and autonomous vehicles, that it's going to pose a challenge, and it's one that at TRL, where we're involved in the research and those kind of things, that I hope that we will keep up with and stand up well to.
Okay, right. We're almost out of time. So what I'm interested now is let's help your viewer who is watching at the moment, and imagine their boss comes up to them this afternoon and says, "So you were watching that webinar at lunchtime. What was it about?" If you had to help them sum up for their bosses Scoot 8, how would each of you do it?
I'll go first so I can steal the words from Chris. So you said it's the first predictive traffic control system, and it focuses on preventing congestion before it happens. I think that's key for us, that predictive element. And with that, we're looking at cutting delays and emissions, and delivering a smoother network within the city, helping the city stay greener and safer.
Chris?
For myself, I'd use even fewer words, and I'd say what we're doing with TRL, UTC, and Scoot 8 is reducing delay where it matters the most for efficient network operation.
Okay, so, right. I am a potential buyer and I'm sold. You've convinced me. I know that that's what I want. What's my next step?
Visit the TRL's website, which is trlsoftware.com. And there's an inquiries form in there, I believe, which is it's quite simple, inquiries at trl.co.uk, or simply contact myself or Chris after the session, and we'll be happy to talk you through what we can offer and where we can go and what's next for you.
Fantastic. Right. Well, and do you know what? We're going to finish 5 minutes early and give you 5 minutes extra of your lunch back. So we're really kind as well. That was Wendy Davidson, traffic engineer at TRL Software, and Christopher Kettell, who is chief technologist at TRL Software, talking about Scoot 8 AI and the brilliant advancements that they've been working on and delivering, and what is happening now to make our networks in our cities more efficient. Chris and Wendy, thank you ever so much for your time, and thank you for your time time to watch this webinar. And as I say, do feel free to share it with colleagues and counterparts, and we'll get the story told to as many people as possible. We'll be back with another webinar on another subject with TRL software. Watch out in your inbox and on Highways News for details of those. We'll talk again soon, and for now, thanks very much indeed for watching.